Alrighty, so this is our first lecture, A.0. Again, I think if you watched, if you're coming from the syllabus intro part 2, we talked about that this doesn't really exist in the textbook. It's more just like a review. I like to call it pre-algebra review. So we're just kind of going over, we're going to talk about fractions, like how to add, multiply, and divide, and parentheses and like the difference of them. So just kind of like, hey, don't forget you need to do this, just by the way. Right, so we're going to talk about fractions first. And so when multiplying fractions, you multiply the numerator and the denominator. So if I have this like little example, if I have like 13 divided by 2, usually we'll use a dot for multiplication instead of like an x, just so you don't think x is a symbol. So, and then times 6/7. So we multiply the numerators and the denominator. So that means I multiply across. So 13 divided by 2. 13 divided by 2, 6 divided by 7. So I'm going to 13 times 6 and 2 times 7. Make that little x if you want. So 13 times 6, 2 times 7. And then 13 times 6, 60. What's 3 times 6? 18. That sounds about right. So this is going to be 78 divided by 14, right? So dividing fractions. Fun fact about me, I did not know how to divide fractions until senior year of high school when I was in Calc 2. So it shows how far you can go without when you just use calculators. So try not to use a calculator a lot. It really weakens your mental math. So you're like, it's like, what's a good analogy for it? Only going to the gym and using like the lowest weight you can. You're still going, you're doing things, but you're not really building that mental muscle. So a calculator kind of takes away that gravity of the weight, if you will. All right. So when we're dividing fractions, we're going to use what's called keep, change, flip. So we're going to keep the first fraction. I'm going to change division to multiplication, and then I'm going to flip the second fraction. So if we use the same fractions we used before, but we divide them, so 13 divided by 2, and we can use the division sign, which is just a blank fraction if you didn't see it. Just a little top numerator denominator with dots instead of numbers. Divided by, oopsies, ugly 6/7. Sometimes I write my fractions a little slanted. But for consistencies, we'll do a flat. So I'm going to keep the first fraction. So the order of this is very important. 13 divided by 2. So I kept that one. I'm going to change division to multiplication. So this now becomes that. And then I'm going to flip 6/7. So flip. It's also, if you've ever heard of reciprocal, I just flip it upside down. So the numerator becomes the denominator comes the numerator. So I get 7/6. And then I use what I just learned in my multiplication of fractions that I multiply across. So 13 times 7 over 2 times 6, which is going to be, what's 13 plus 78? 81, 91? 91 divided by 12. And I'm pretty sure that doesn't reduce at all since 13 and 7 are primes. All right, cool. So if you didn't remember how to divide fractions, I probably would have been a year away from learning it if I was in your shoes. So no hard feelings. We also can write division of fractions instead of using the division sign. I could do something like 13 divided by 2, and then make it like a big fraction. 6 divided by 7, where it's kind of clear that this is a fraction and this is a fraction within another fraction. So we can also write it like that, and it works the same way. Okay, so that is equivalent to using the division sign. All right, so when we're adding and subtracting fractions, what do you think that will need? Just think for a little bit. What do I need to do before I can add and subtract some fractions? I need to get what is called a common denominator. All right, so if we're doing our favorite fractions again, let's do 13 divided by 2. Let's do plus 6 over 7. I need a common denominator. What that means is I need the denominator of the first fraction and the second fraction to be the same. So I can't just add across like I would with multiplication. It doesn't work. I like to think of multiplication as like the big brother to addition, but it's not very useful to think in that way right here. So let's write in red really quickly. So what I cannot do is say 13 plus 16, oh, not 16, 6 divided by 2 plus 7. That doesn't work. So how can I get a common denominator? So far, I've only learned how to multiply and divide. So our best bet is to what I call multiply by a fancy 1. What I mean by fancy 1 is it's 1. You can multiply anything by 1 and it's still itself. But it can help change the denominator. It also will change the numerator, which is good. You can't just change the denominator. So 2 and 7 are actually both prime numbers. They're not divisible by anything other than themselves. 2 is the only even number that is a prime number. So I can't, I'm not going to find something like, if I'm not, I need to multiply them together basically. So for 13 over 2, and this works for any common denominator. Sometimes there's common denominators that are smaller than if you just multiply the two denominators together. So if it's 13 over 2, my fancy 1 is going to be 7 divided by 7. So that's what I mean by multiply by a fancy 1. And then we're going to say plus 2 over 2. And the reason I'm doing this is because I'll have 2 times 7 in the denominator for my first fraction and 2 times 7 in my second, and that will give me a common denominator. So 13 times 7, we found out earlier was 91. We know that is 14, plus 6 times 2 is 12, divided by 14 again. All right. So these are my fancy ones. And I just chose the reason I chose 7 over 7 is because 2 times 7 is my common denominator. All right. And we'll talk about least common denominators later. Remember, this is just a review. And then now that I have a common denominator, I can now put them together. But again, the denominators do not add. They just come together, right? So it's going to be 91 plus 12 over 14. And that's going to give me like 103 over 14. That's my face. And I usually like to box my answers. It's a good practice to do that in mathematics. Helps us find your answer really fast. And the same thing works with subtraction. So I would do like 13 over 2 minus 6 over 7. I would again multiply by a fancy 1. So 13 over 2. Oh, not 13 over 7. 2, 7 over 7. minus 6 over 7 times 2 over 2. We're going to get something similar, 91 over 14 minus 12 over 14. And we'll get 91 minus 12. So it's the same process, except there's a plus here. Oops, should not underline that. There is a plus right here. So there's a plus when I bring them together. So when there's a minus here, you can think about it, if I attach this negative to 12, like 91 plus negative 12, which is the same as minus. And then that would be 89 minus 10, 79 minus 14. And there you go. If that was a little too fast, pause now and watch it over, or email me. We can talk about it. I'm hoping this is mostly kind of review. All right. So now we're going to talk about parentheses and distributions. I see these misused a lot last semester, and people not really understanding the difference and kind of how multiplication when you're using parentheses works. So think of parentheses as commas. They really drastically change a sentence, right? They're extremely important and change the meaning of an expression. An expression just doesn't have an equal sign. It's not an equation. So 2 times, sometimes we don't even add a multiplication sign. We just put a number in front of a parentheses and we assume multiplication. So 2 times the quantity 3 plus 4, that's how I would verbally say that expression, is different from 2 times 3 plus 4. Right, those are different. I'm multiplying 2 by 3 and 4 here in the first one. So this would be 14, no, 7 and 2, so 14. And this is 2 plus 3, which is 6, and this is 10. So we can clearly see that it doesn't work like that. So we do what's called distributing. So in distributing, you distribute the thing outside the parentheses to everything on the inside. If you ever remember hearing foiling, first, outer, inner, last, it's how to distribute a parentheses times another parentheses. So to everything on the inside. And by everything, I should say every term. Terms are separated by addition and subtraction. Again, this is a review, so we'll go into more depth about that later. So 2, I would read this as 2 times, oh my gosh, I keep trying to hit the pointer, not the laser pointer. 2 times the quantity x plus 3. That's how I would read that. So I usually like to draw these arrows, so like 2 to the x and then 2 times the 3 would give me, so 2 times x, we would just write that as 2x plus 2 times 3. That's going to equal 2 times x. I don't know what x is. Just random variable plus 6. All right. Multiplication is this really cool thing. It's what's called commutative. A times b is b times a. Means I can multiply on either side. Usually when something's in front of it, like in this case, I assume multiplication, but it's kind of weird if I just put a 2 behind it. You'd be like, I think that's an error. So we usually like to do a multiplication sign. This is me kind of harping on that math is a different language. So I'm trying to give you a little freshening of how we write things in mathematics, right? But the distributing goes the same way. I can now distribute 2 to the x, 2 to the 3. So I'll have x times 2 plus 3 times 2. And we usually like to write number then variable. So it'll be 2 then x is the proper way of writing it, plus, and then 3 times 2 is just 6. Again, so same thing, just written a little differently, the beauty of math. All right, so something that is often forgotten is the negative signs. So if you want to think of like a negative as like almost like a -1, like there's like a secret 1 right here. So I can, it's like 2 minus the quantity x plus 6, or I can say like 2 plus -1 x plus 6. That's another way of thinking about it. Um, but it works the same as if I just distribute. Let me erase this one right here. This negative versus a -1, it's the same thing. So negative x, -6. So it's going to be 2 minus x minus 6. It's very often people forget to distribute the negative to the second thing. And then this would be like negative x, 2 minus 6 minus 4. Another thing is we write in decreasing powers. So, and then a constant is always last. So I wrote x minus 4 instead of -4 minus x. It's not incorrect to write it -4 minus x. It's just more common. Kind of like if you spoke the way Yoda spoke. It's not incorrect. It's just a different way that's not as common. All right. So the reason I showed you distributing like this is kind of how it works for this next example. So we have 3x minus 2x minus 4. So I'm going to take the -2 to both of them. So it's going to be 3x minus 2x minus 2, and I put a -4. So that -4 is telling me when I write -4, I'm not subtracting and multiplying these things together. Oopsies. Which is going to do, if you're just kind of like being a refresh to math, it might be good to do one step at a time instead of like trying to combine factors. So what's -2 times -4 would give me a +8. And then I can 3x minus 2x, which gives me x plus 8. Yeah. So the reason I drew it like this is we would get something kind of like 2 plus -x plus -6, which is, again, adding a negative is just subtracting. So it's either way you like. Just remember to simplify always at the end. Oh, let me box my answers. All right. So that is all of A0. If this felt like it was a little fast, it usually is a lot slower in class. We talk about things more, there's more answer and recall. So that's why it'll look like you won't have a lot of lectures, but it'll add up if you like pause and stop. And sometimes I write too fast. You can't tell me to slow down, and I'm sorry. So yeah. All right. So you have one more thing of today, 8.2, and I'll see you there in a second.